So we've played around with what happens when you have all three variables squared and you mess around with their signs. And we've seen the different types of quadric surfaces that you can get. There are four of them: an ellipsoid, the hyperboloids of either one or two sheets, and then a cone. So paraboloids are what happens when one of the variables is not squared, but the other two are. And so you can identify these immediately when you have an equation just by looking at the squares. If there is one variable that is not squared, so in this case I'm showing you the situation where z is the non-squared variable, then it's immediately going to be a paraboloid. And there are two types of paraboloids. We're going to look at the elliptic paraboloid first. When you put the non-squared variable on one side and you have the other variables on the other, then what you're checking for is whether or not the squared variables are both positive, or are they opposite signed. So in this case, they're both positive, and they have the same sign, and so that's important. That's what's going to make this elliptic in nature. If I plug in various values of z on this side over here, I'm going to have a constant equals to an equation that has terms that look like the equation of an ellipse. We'll see that the non-squared variable is going to be sort of the axis that you're opening on, and whatever the coefficient associated with that non-squared variable will tell you which direction it's opening. We know that parabolas in general open according, if the coefficient of the squared term is positive, then that means that they're going to open in the positive direction. And if it's negative, parabolas open in the negative direction. And so that's where the role of c is going to come into play. So once you have arranged things so that your two squared variables are both positive, there may be a negative sign hidden inside this coefficient. My picture is going to show the case where c is greater than 0. At the end, I will talk to you, I'll show you what happens when we flip it and think about c being less than 0. So let's take a look at the traces. When I am in the xy plane, that means z is 0. And if z is 0, I'm basically just saying 0 is equal to x squared over a squared plus y squared over b squared. Now we've talked about this term before. This is a sum of squares, so it's greater than or equal to 0. So the only way it is equal to 0 is if x and y themselves are 0. And so what we get here is just a point, and namely we're getting the origin. That's why we're seeing this point here on the graph. So this is a point, 0, 0, 0. Now I could shift z up to z equals c. If z is equal to c, when I come over to this equation, the left-hand side becomes c over c, which is just 1. So that's why we see this equation here. And this is the standard equation of an ellipse. So when z is c, we get an ellipse. So I'll go ahead and let's pretend that this is c up here on my graph. Now, if I look at z equals negative c, then when I sub in negative c, the left-hand side of my equation becomes negative 1, and there is no solution to this equation because it's impossible to add two numbers that are greater than or equal to 0 and somehow get a negative value. So this has no solution, which is why you don't see any graph below the xy plane in my particular picture. So now when I look at the yz plane and I set x equal to 0, that term is going to drop out. So that term is gone, and we're left with z over c equals y squared over b squared. If I rearrange that equation, I could solve, and I could say, hey, that's z equals c over b squared times y squared. Now if we investigate that equation, b squared is always positive or greater than or equal to 0. And I have, so the sign of this coefficient is going to be determined by the sign of c. If C is positive, this is a parabola opening up. If C is negative, it is a parabola opening down. So we get a parabola opening up when C is greater than 0 and down when C is less than 0. Now, this is the specific case where Z is my non-squared variable, but if X was my non-squared variable, we would either get a parabola opening forward in the positive X direction or backward, for example. If I look at the XZ plane, this time the Y term drops out and I get a similar looking equation. And when I go and I solve that, I get Z equals C over A squared times X squared. And again, the sign of C is going to determine which direction this is opening. It's regardless of whether or not I'm in the XZ or the YZ plane, I'm getting a parabola that is opening on the Z-axis. So this is a parabola. It will be up if C is greater than 0 and down if C is less than 0. So coming over to my picture, this outer parabola that you're getting is coming from the YZ plane trace. And the XZ plane trace produces this parabola. And so together you get something that looks kind of like a parabolic bowl, opening only in one direction. And that was because you don't get any solutions when Z is equal to negative C. Now again, I had said that this is the graph of the case where C is greater than 0. If C was less than 0, basically what would happen is you would get a rotation of this picture, and it would be down here instead. Now that is still, in this situation, because C is less than 0, you would be opening, all of these parabolas in my traces would be opening down. And this would still be labeled down here. This would still be the value C. It's just that there would be a negative sign implicitly in the value of C. Now, if I were to change which variable was my squared variable, then all that's going to do is either make something that's going to open in the positive X direction if A is positive, or it'll open in the negative X direction if A is negative, if X was my non-squared term, or I could have Y as my non-squared term, and I would either open to the right if it's positive, if B is positive, or I would open to the left if B was negative. So elliptic paraboloids are not too bad to draw. Your goal is to just identify which is the non-squared variable and what is the coefficient of that non-squared variable. When you've arranged it such that the two squared terms are positive on one side, then whatever you get on the other side, if there's a negative, it tells you it's going to be opening in the negative direction. If it's positive, then it's going to be opening in the positive direction. And so that's it.